Hi, everyone. Just going to let folks trickle in. And hopefully none of you can hear too loudly the lawnmower right outside my window. As you come in, say hi. Tell me where you're calling in from. Maybe give me a sense of how long have you been studying for the GRE? Great. Welcome, Leroy. Just getting started. I like to hear that. Is there anybody else? Where are you calling from? How long have you been studying for? All right, we're having some shy folks on the chat today, and that is okay. So hi, everyone. Oh, great. Here we have Mackenzie, just getting started from Madison. Silas, just getting started. And Kay Murali, it's been up to a week. Great. So we've got people at the beginning of their studying. Excellent. So today is going to be a really helpful lesson for you, I hope. What we're looking at today are exponents. And chances are this is the kind of thing that there might have been a point in your life when your math teacher had you learn all these exponent rules and play with these, and you felt really good about them, at least until you had the test the next day, and then you forgot about them. And then all of a sudden you have, here they are showing up again. And so what I want to do today is to kind of in detail go through all the different exponent rules, what exponents are, how they function, what we can do with them. And then we're going to start working on like how those can fit into GRE problems. So our first half is on fundamentals. Our second half is looking at actual GRE questions together. So to start with, what's an exponent? Well, when we're looking at an exponent, we've got something that looks like this. We've got a big number and a small number, and just some words I'm going to be using today. The big number is the base, and the little number is the exponent. And what's important to keep in mind is exponents are a form of shorthand, and they're shorthand for repeated multiplication. So it's easier to write this than to write it as it is expanded out. 2 times 2 times 2 times 2. But that's all it is. And as we go through this, I just want you to keep in mind, all we're dealing with is repeated multiplication. And if any of these rules get confusing or you get lost at any point, you can always expand things out to make things a little simpler. And also remember that doing this means that 2 to the 4th is just a number. And we could calculate this with our calculator at 16. So our exponent rules. First one is the basic one that we just looked at, right? That something to a power is just repeated multiplication. And my calculator can do this. I have it. It's a little bit annoying, right? Because on the test, you don't have an exponent button. So you're going to have to do 2 times 2 times 2 times 2 to get our answer. But that's kind of the simplest version of this. We also might see a negative exponent. And your calculator can't help you here. We have to know what this means. A negative exponent just means 1 divided by a positive exponent. So 1 divided by 2 to the 4th, or 1 over 2 to the 4th, 1 over 16. We have 0 to a power. Calculator also can't help us here. Keep in mind that 0 to any power is always 0. Because all we're doing is just multiplying 0 times itself 50 times, still going to be 0. So nice thing to remember. But on the other hand, if we have 50 to the 0 power, calculator also can't help us here. We have to know that anything to a 0 power is equal to 1. So a couple rules to keep in mind. How to use a negative exponent, 1 over the positive exponent. 0 to anything, any power is equal to 0. anything to the 0 power is equal to 1. Now I want to unpack negative exponents a little bit more, right? So we saw if we have a negative power, that's 1 over the positive. But what if we see this? 1 over a negative power. Well, I know I'm supposed to do 1 over the positive power here, right? So I could write this as 1 over 2 to the 4th, but that's awful. And we have to think about our fractions rules, and we can do this. There's nothing wrong with it, right? But it's like, okay, 1 times the inverse of this. And if I do that, I realize that, when you divide by a fraction, you flip and multiply. So if I do 1 times the inverse of this, 2 to the 4th over 1, that's just going to be 2 to the 4th. So the easier way to think of this is, instead of thinking of it as 1 over this, just think, okay, if it's a negative exponent, it either goes from the top to the bottom, or it goes from the bottom to the top. We just flip it over. That's the easiest way to think of it. Now, if we've got something like this, a negative exponent over a negative exponent, now we understand how to do this. We can just flip it around. If, however, we had another case, let's imagine we've got 3 to the 3rd, positive 3rd, over 2 to the negative 4th. 2 is the only one that's negative here. So we're going to leave that 3 right where he is. And the 2 is just going to move from the bottom to the top. We would just multiply these together. So, any questions about these negative exponents before I go on to a couple other rules? Okay. So, now we want to deal with combining exponents. And this is now where the rubber really hits the road and how we're going to start really see this on GRE questions. Is when we're multiplying with exponents, dividing with exponents, or raising a power to a power. I want to just take a second and see, do I remember what these rules are? Maybe it's ringing a bell somewhere distantly. When we multiply, we're going to add the powers. So 20 plus 30 gives us 2 to the 50. If we divide, we subtract the powers. 20 minus 30 gives me negative 10, which would be the same as we saw as 1 over 2 to the 10th. And if we've got a power raised to a power, we multiply. 20 times 30 gives us 600. In a second, we're going to see kind of why this is, but we might want to just start by just kind of memorizing this and saying, all right, multiplication turns into addition, division turns into subtraction, exponents turn into multiplication. For me, somehow as a kid, I always thought about this as like, oh, the numbers get smaller, and so the function gets smaller, right? We go from exponent to like its little cousin addition. Same, division turns into the smaller one, subtraction, exponents turn into the smaller one, multiplication. Somehow that made sense to me, but maybe it helps you. Notice though, something is really important is going on here. That the bases are all the same. We're going to see in a little bit that this is not the case if the bases don't match. So we can only do this if we have the same base. Now, I promised I would tell you kind of why this is. So let's unpack this a little bit. When I'm multiplying by the same base, remember all an exponent is just shorthand for repeated multiplication. So let's expand these out. I've got 3 to the 5th times 3 squared. Well, that just means I have 3 times itself 7 times. 5 plus 2 is 7. Similarly, if I'm dividing 3 to the 5th divided by 3 to the 2, oh, I've got 5 3s divided by 2 3s. I can cancel these out. I'm left with 3 3s. Power raised to a power. So all this is 3 squared times itself 3 times. And we can expand out 3 squared times 3 squared times 3 squared. When I count all these up, I see I've got 3 to the 6th. So it can be helpful, especially early on, to really fully expand it out like this, if only just so to help you understand like what's going on, why am I doing this? This might help you understand the rules, which might help you learn them better and memorize them better. But ultimately, when we get to the test, we don't want to be doing this if we can avoid it. Still, if ever you're stuck, when in doubt, expand it out. You can always do this. There's nothing wrong with it. And it can sometimes make it clear until you're comfortable with the shortcut rules. Now, again, notice here, our bases are the same. What happens if they're not? Well, we're multiplying. You might think, okay, cool. Can I just like do 2 times 3, which is 6 to the 50? And the answer is no, you can't. The bases have to match. This is just this. So we would just leave it that way. But if I had this, you might say, all right, well, I just have to leave it that way. But I might notice, like, wait a second. 2 and 4, these are related numbers in a way that 2 and 3 aren't. So if I see I've got different bases, I'm going to ask myself, can I use factoring to make the bases match? And in this case, I can, because I can rewrite 4 as 2 times 2, or as 2 squared. Once I do that, I'm golden. Great, I've got 2's all across the board, so I can just simplify this. I make my 2 squared to the 30th into 2 to the 60th. I'm multiplying now, the bases are the same, and I can add those exponents, boom. Now, in a second, I'm gonna give you some questions, but before that, let me take some questions. Any of this, I know we're moving a little bit fast. Does any of this feel confusing? Anybody feel lost about any of these things? And if you feel good, just tell me all good. All right, great. Seems like folks are doing well. Great. So let's try this out. I've got a couple of practice problems for you, just practicing these rules. I'll give you a few minutes. Let me know when you're done. Yeah, let me know when you're done. Okay. Sorry if you haven't quite finished. Let's take a look at the solutions here. So here we've got our same bases. We're going to add our exponents. Same bases, multiplication. We add the exponents. Power raised to a power. We multiply those exponents. Power raised to a power. We multiply those exponents. Same base, we're dividing. We subtract the exponents. Okay, I've got 4 more now for you, a little bit trickier this time. Once again, let me know when you're finished. All right, I'll stop you there. So first one, fairly straightforward. We again have same base. We're going to subtract these exponents. Here again, same base division. We subtract, we end up with 3 to the 0, which equals 1. As we saw before, anything to the 0 power is 1. This maybe kind of shows us why, right? These are all going to cancel out. Here we've got division, same base, so we subtract. 2 minus 8 gives us -6, which we could write either way. Now here we've got a little bit of a tricky one. In order to move this forward, we need to make the bases match. So to do that, we need to factor our 8 and call it 2 to the 3rd. Now we've got all 2's. 2 to the 3rd is going to be 2 to the 9th. Since our bases match, we can add those exponents together. Or we might recognize 2 to the 3rd is 8. So we, instead of matching it as 2's, we match it as 8's. Both perfectly fine ways to go, and get 8 to the 4th. And these are equivalent answers. So this last move is one we're going to practice a bunch today, and it's one that ends up being really helpful, as we're going to see in quantitative comparison questions. Before we get to that, though, just want to review our exponent rules. We need to know how to deal with a negative power, that a power of 0 is always 1, and 0 to any power is 0. If we're combining multiple exponents, we need the bases to match. When we multiply exponents, we add the powers. When we divide the exponents, we subtract the powers. If we raise a power to a power, we multiply those powers. Good. So that's kind of the fundamentals here, but now let's start using it in the context of GRE type questions. So I've got the first one here. Send me your answer when you have it, please. Okay. So we're looking for x, and we might look at this and at first, if we hadn't been prepped the way we're prepped, panic and feel like, oh my God, do I need like natural log or something? Like, we don't have that here. How am I going to solve for x when x is up there? Well, what we want to do is say, can I get this to be 2 to some power? If I know this is 2 to some power, that'll tell me what x is. So we're dealing with an exponent problem here. We recognize that we've got all these exponent things. Very helpful to categorize a problem before you start answering it. And so we set this up, and our goal now is to try to get this left side to be 2 to some power. So let's do a little factoring. We can rewrite 4 as 2 squared, rewrite 8 as 2 cubed. I'll just say right now, it's pretty helpful to know that 8 is 2 cubed, that 16 is 2 to the 4th, that 32 is 2 to the 5th. Helpful to just memorize those. I'll write them on the board here. They show up often enough that it's good to just know them. And now from here, I can start cleaning things up. I've got my powers raised to powers, which I can multiply. Now I've got the same base, so I can add these exponents and get 2 to the 19th equals 2 to the x, which tells me x has to be 19. because there's no other number that I could raise 2 to that would get me 2 to the 19th. So our answer is E. Now, when you're working on a problem like this, as you're studying, let's say I either got it wrong or I'm like, man, that I got it, but it was like, oh, I don't know how I would know to do that. How would I possibly realize this is my solution? That means this is a good problem to make a study card off of. So we might recognize, okay, looking at this question, I can turn this into a flashcard with the form when I see, I do. And this can be really helpful to study with, right? You can make this flashcard and then look at this, just this thing, and think, all right, what does this tell me if I see this on a problem? Well, I'm dealing with an exponents problem. That's the first thing, categorize that. And I want to think about my exponent rules. I'm recognizing I have a variable in the exponent. Okay, that's a particular kind of thing. What am I going to do with that? That means I need to get this basis to be the same, set the sides equal to each other. I'm going to do that using my exponent rules. So again, this question of how would I know to do that? You can just answer it for yourself on a card and study it. The test is all about recognizing patterns. So if you can give yourself the tools to study those patterns, you'll have a better chance of recognizing them. And then on the card, you can put how the solution works as well. So I want to encourage you as you're studying, don't just churn through problem after problem after problem. Make yourself the study materials that are going to make you more likely to get something right the next time you see it. Okay, let's try another problem. Send me your answer when you have it, please. Okay, good. I'm getting a couple of people giving me answers and giving me a different answer, then going back and forth and back and forth. Great. This is a little bit tricksy. So I would say to make this a little bit easier, this complicated form, let's simplify it by thinking of it as happening in these two discrete parts. We've got a top fraction and a bottom fraction. Now our top fractions may be kind of easy to deal with, right? 1 divided by 1. Why are they so mean writing it this way when they could just say 1? Now the bottom fraction, well, we know how to deal with a negative exponent. we just flip it around and make it positive. So this is just going to be 5 squared, which is equal to 25. If we put these together, we get 1 over 25, which is choice A. So, splitting it into parts and staying organized with your work. If you're trying to do this in your head and you're like flipping and flipping and flipping, you're bound to get it wrong. Okay, let's try another. We're now going to move into the world of QC problems. Send me your answer to this when you have it. Now, just a note, QC, or quantitative comparison, for those who are just starting out, always look like this. You've got quantity A, quantity B. Sometimes they give you some info up top. And our answer choices are always the same. You're picking the greater side. You're picking C if they're equal. You're picking D if it can't be determined. So once you determine this, let me know in the chat. Okay. So looking at this problem, we may think, wait a second, what am I supposed to do? We learned all these rules. We didn't learn any kind of rule about subtraction. Well, let's just notice these numbers aren't so big. So the best thing to do is just turn these exponents into numbers. And we're going to see that quantity A is greater. So this also shows us, sort of through the sideways door, that we don't have a rule about subtracting exponents. We can't just subtract the exponents there. We have to expand it out. We only subtract exponents when we're dividing the base by the base. All right, let's try one a little bit trickier. Again, send me your answer when you have it. Right, I'm going to stop you there. So looking at this, these are all numbers, right? So we could theoretically put this all in our calculator, but like, man, that's pretty annoying. A better idea might be to say, can I simplify anything going on here? So let's do a little bit of factoring. If we do a prime factorization of these numbers, and just to see how that's happening, we've got like 75, which I can break down into 25 times 3. 3 is a prime number. So I can break down 25 into 5 times 5 times 3. These are now all prime numbers, meaning they can only be divided by 1 in themselves. This is the prime factorization of 75. And let's keep in mind, when I see complicated exponent problems, oftentimes a good way to simplify is by prime factorization. So if we do that, we prime factorize 75 into 3 to the first 5 squared. 45 becomes 3 squared 5 to the first. Now we've got this whole thing in terms of 3s and 5s and 2s, and that's going to be a lot easier to start canceling out with. So I can just multiply all the tops and multiply all the bottoms. So I've got 2 to the 4th, 3 to the first times 3 squared gives me 3 cubed. 5 squared remains like that. I add the 5s in the bottom. I add my 3s in the bottom. I square that 2 squared. So using all of our different exponent rules here to now use the last one, which is the subtraction one. 2 to the 4th divided by 2 to the 4th is going to cancel out. 3 to the 3rd divided by 3 to the 4th gives me 1 over 3. These are going to cancel out. Boom, I'm left with 1/3. If we're good at our exponent rules, this is a lot easier to do than trying to plug this into your calculator. Let's now look on the right. Again, I want to try to prime factorize. So I'm going to change that 10 to 5 times 2. And I'm going to change that 4 to 2 squared. Doing that, now I'm dealing with all of these nice same bases. I can do the same thing I did over here. Combine my 2's over here and activate this exponent over here. So I get 2 cubed, 3 squared, 5 to the first over 2 to the 4th, 3 to the first, 5 squared. Now I've got to do a little bit of canceling. So this is going to cancel this out, make it 5 to the first. These two are going to cancel out. This will be 3 to the first. These two will cancel out, leave this on the bottom, 2 to the first, which gives me 3 over 2 times 5, or 3 over 10. If I want to now make a comparison here, either I can eyeball it if I'm good at estimating with fractions, or I can convert into decimals and recognize A is the bigger choice. I like this problem because at this stage in the game, early on, this may feel really hard because it's a lot of mechanical action that maybe you're feeling rusty on, or maybe it's feeling new. But I would encourage you to come back to a problem like this, or come back to this video and redo this problem in a couple of weeks after you practice your exponent skills for a while, because you want to be able to do these moves very quickly, ideally. Until you're there, don't rush. Take your time, think deliberately about them. You can even have a cheat sheet of all the rules next to you as you're practicing. Okay. Any questions about this before we move to our next problem? Okay. So let's try another question. And I would say for this next question, think about prime factorization as a tool. Please send me your answer when you have it. Okay. So first tip for a problem like this. Let's say I look at this and I'm like, oh man, I do not know how to approach it. I need to take a smart guess. Well, I could just kind of eyeball it. But if I want to make my guess a little bit smarter, I might recognize there are no variables. So that means I can eliminate D. Because D means it depends. Sometimes it's B, sometimes it's A. But if this is just a number and this is another number, there is definitively one that's bigger or they are equal. Same way if it were 2 and 4. So if there's no variables and I have to take a guess, it's got to be A, B, or C. Now, how am I going to get there? I think, all right, cool. 2 times 7 is 14. 5 plus 10 is 15. So these are equal, and it's C. But that's not the case. Why? Because the bases don't match. So I can't just do that. I can't do that. I only add the exponents if the bases match. So what am I going to do instead? Well, these numbers are too big for the calculator. Remember, the calculator doesn't have an exponent button. So I couldn't just plug this in. And if I did, I'd probably get an error sign. So what am I going to do instead? There we go. What am I going to do instead? If I can't calculate it, instead, I'm going to try to compare. Because that's my goal on quantitative comparison, they're not asking me for the value here, they're asking me which is bigger. So let's see what that looks like. To compare them, I need to match the bases. Just looking at this, I couldn't tell you which one is bigger. So I want to get this to look like this. To do that, well, I'm lucky. 14 breaks down into 2 and 7. So I can just break this up as 2 times 7 to the 15th. And then here's another exponent rule we didn't really talk about. If we have multiplication in the parentheses, we can distribute that exponent. Once I do that, now I've got a 2 and a 7 versus a 2 and a 7, and it's quite clear the answer is B. So the rule here, which we didn't talk about before, is if I've got, say, AB squared, that's going to be equal to A squared B squared. And the same goes in the other direction. If I've got multiplication raised to a power, I can distribute. If I have the same power with multiplication, I can multiply the bases. The same is also true of division. If I've got division raised to a power, I can distribute that power. So distribute exponents over multiplication and division. But don't distribute over addition or subtraction. If I've got A plus B squared, it is not equal to A squared plus B squared. No, no, no. Instead, we would need to FOIL that out, right? Because that's going to be A plus B times A plus B. And FOIL, which is kind of a different lesson, we would end up getting A squared plus 2AB plus B squared. Very different from A squared plus B squared. So I can distribute over multiplication and division, not over distribute addition or subtraction. All right, let's try another problem similar to this one, but a little bit trickier. So see if you can get the two sides to talk to each other. Match up the numbers so that we can make a comparison. Send me your answer when you have it. So if you find yourself stuck on this problem, remember again, if I have to take a guess, I can get rid of D. Again, we have numbers that are too big to calculate. So we're going to need to compare them. And to compare these, well, I've got kind of a problem here. On one hand, I've got a larger base, but a smaller exponent. I can't compare across these. So I need to try to make things match. Get these to talk to each other. So either that means I'm going to match the bases and compare my exponents, or I'm going to match my exponents and compare the bases. Now, if I'm looking at this, first thing I might notice is if I do a prime factorization of 92, I'm going to get 46 times 2. 46 breaks into 23 times 2. Whereas 10 is going to break down into 2 and 5. So these bases are not actually going to match each other if I do factoring. Already, that should tell me it can't be C. There's no way these could be the same as each other if these bases are incompatible in terms of their factors. So it's not C, it's not D. Again, if I need to take a guess, I'm going to guess A or B, move on, take the rest of the test. But let's try to look at some ways to do it. So let's try to match these bases. Now, how could that be possible if I just said these factors don't match up? I can't make them the same. Well, I might say 92. Let's round it up a little bit. Let's call it 100. It's a little less than 100. Well, that's kind of helpful for me. Because if I'm thinking of this as 100 or less than 100, well, I can factor 100 to be 10 squared. Now I can do power raised to a power. Aha. So I've got a number that's less than 10 to the 4,000 versus 10 to the 4,000. We know which one is bigger. That's one way of doing the problem. So we round this number so that we're able to compare the bases. Next way of doing it would be as if we try to match the exponents. Now I'm going to work on quantity B, and I'm going to say, well, I want this to be something to the 2,000th power. So I'm going to kind of reverse engineer this exponent here. Call it 10 squared to the 2,000th. How did I know to do that? Because I knew I wanted something, I wanted 2,000 on the outside. And I asked, what do I need to do to this to get there? I would divide it by 2, which would mean putting it inside parentheses there. Now I activate this 10 squared, call it 100. Ah, so easy now. I know 100 is bigger than 92. They're both to the same power, so I can make my comparison. So, saw a lot of things today. We learned our exponent rules, right? So if I'm multiplying exponents with the same bases, or actually, let's do this. Same bases, and I multiply, I'm going to add the exponents. Same bases, and I divide, I'll subtract the exponents. If I have a power raised to a power, I multiply the exponents. If I've got multiplication raised to a power, I can distribute the exponents. If I have division in parentheses raised to a power, I distribute. If I've got addition or subtraction raised to a power, I do not distribute. When I see complicated exponents in QC or otherwise, QC meaning quantitative comparison, I'm going to try to prime factorization as a way to simplify. If I'm comparing complex exponents in QC, I want to make things match. Either match the bases or match the exponents. So we got to know the rules, and we need to know how can we use these rules on the exam. We could call these like rules and strategies. And I would really encourage you, as you continue to study, to not only think you need to learn the rules, practice recognizing the kinds of things the test will show you and what ways you have of responding to them. Start seeing the patterns in questions. And when you see a question, you're like, I would never think of that solution. Ask yourself, what could I memorize that would help me think of that solution next time? All right, I want to thank you all for a wonderful hour session. I'm going to stop the recording and then take questions in just a second. If I can figure out how to stop the recording. There we go.